Good day and welcome back to another lesson on the whiteboard series. Today we'll be looking at some common questions, or rather the most common questions on this topic of heat. Please view my previous video on heat revision before coming on board this lesson, as that will greatly help you to understand the fundamentals before you attempt any heat questions. Now in this video, I will also be going through some basic steps or ideas on how you can actually attempt questions. These steps are common throughout all questions. It doesn't matter which topic or which type. This should be your thought processes when you attempt a question. Now, I do not expect you to write down everything each time you attempt a questions in the actual exams, because that will waste a lot of time. However, it would be good if doing your daily assignments, you do that, because it becomes a habit and your mind will actually be accustomed to having that thought process whenever you approach the question. And that will really help you greatly narrow down and be targeted in your answers. So without further ado, let's start. Alright, so today we're doing on heat. Now, whenever you do a question, it doesn't matter what question, the first thing you should always do is to identify, alright, what exactly is the topic. And then the second step is to identify which concept are they testing you on with regards to the topic. So you will probably ask me then, Mr. Chong, what is a topic and what is a concept? Now, a topic is basically how you would actually categorize concepts in a very large sense. So for example, examples of topics versus concept. So for example, for topics, right? An example would be heat. So what is a concept? So in the topic of heat, we have learned a few concepts. So for example, we have talked about heat transfer, whereby heat always travels from a region of higher temperature to a region of lower temperature. We have also learned about good and poor conductors of heat. So for example, metal is a good conductor of heat, plastic is a poor conductor of heat. We have also talked about expansion and contraction. So these are concepts, ideas related to the topic. So if I'm talking about something else, like let's just say I'm talking about the water cycle. So under the water cycle, this big topic, you have evaporation and you have condensation, right? So those are the topics. And we also have another example would be your respiratory system as a topic. However, your concepts will include things like gaseous exchange, as well as what is respiration, which is actually the process of gaining energy from your food in the presence of oxygen. So I really hope you take some time to understand this, because I'll be referring to these thought processes very often in every question. This will help you understand how do you arrive at the correct concept tested. So let's start off with the first question. Now, the first thing you do in attempting question is to read the question. Now, when you are reading the question, okay, so I'm just going to pen it down. Read question. Now, when you read the question, what you want to be looking out for is actually keywords or key ideas that will help you identify which topic it is. So second step would obviously be to identify your topic, and then after that take some time to think about the keywords as well as what are the ideas presented in the question, and then zero in on the concept that is being tested. So for example, question number 1, a metal spoon was heated over a candle. It is then placed in a glass of water as shown below. They show you a diagram, and then after that put a tick in the correct boxes based on the experiment shown above, and then they ask you to explain your answer. So straight off my mind, I see words like heated. So this would tell me that, okay, the topic should be heat, which I'm not going to write it down because this whole paper is about heat. Then the next thing they ask you is that you see the word increase and decrease in temperature. So this will give you a good idea. Okay, so there is a change in temperature. So in order for something to change temperature, whether is it increasing or decreasing, there must be a transfer of heat, right? So based on this fact, I can actually know that what I'm looking at potentially would be, for the concept, would be transfer of heat. And the process skill that they are testing me on is for predicting. Now usually when you want to predict something, you need some prior knowledge to help you anticipate what is happening. So that's where you draw on your prior knowledge. So we know that this is talking about transfer of heat. By identifying my concept, I can now zoom in and think about what are the concepts, key concepts, already key ideas associated with this concept. So the key idea associated with this concept, if you remember, would be that heat always transfer from a region of higher temperature to a region of lower temperature, if you remember that. Okay, so let's go ahead and pen them down. Now, sometimes I would use short form, like instead of spelling temperature full, I would just put temp. But please, in exams, for your sake, spell it in full. Alright? I'm going to just highlight higher temp to a region of lower temp. So, right off my mind, I already know that this is the key idea for the concept of heat transfer. When I'm doing this question, I should be applying this key idea. So, looking at this question, they're asking you, alright, the temperature of water, did it increase or decrease? So, I need you to imagine that you are the water, alright? So, if they're asking about the water, you need to be the water. And then you ask yourself, okay, am I going to increase or decrease in temperature? Now, if I'm the water, alright, and using the key idea of heat transfer, I would know that I should be gaining heat in this case. Alright, why is that so? Now, remember the key idea behind the concept of heat transfer is heat always transfers from a region of higher temperature to a region of lower temperature. So the first thing I need to do is to determine which region is the higher temperature and which region is the lower temperature. So just by looking at this, I would know that my spoon should be of a region of higher temperature. So I'm going to put an up arrow to represent that. simply because it was heated over a fire. Okay, and my water over here is of a region of lower temperature, right? 30 degrees. So based on this, I know that my spoon is of a region of higher temperature. Heat will transfer from my spoon to my water, and therefore my water's temperature should be increasing. All right, so therefore answer is increase. And then for the next part, the temperature of the spoon should decrease because heat has been lost from your spoon over here, region A, to region B. So because heat is being lost from the spoon, your temperature should decrease. Now, the second part of the question requires you to explain your answer for part A1. Sorry, for part A. Now, because they are asking you for two items, water and spoon, you are going to have to explain for both. The key concept here is transfer of heat, and what is related to transfer of heat is talking about heat moving from a region of high temperature to a region of lower temperature. Therefore, that idea needs to be in your answer. So to help us with this, I have come up with a strategy. Now, whenever you're talking about heat transfer, this is the strategy you should use. HDO. H stands for heat, D stands for direction, O stands for outcome. Now, you realize that this HDO is adaptable to various concepts such as expansion, all right, and poor and good conductors of heat, all right. So you don't really have to worry to say things like, oh, Mr. Chong, do I have to memorize a strategy for every single concept? Well, if you understand the fundamentals, it's good that you memorize it, but if you the ultimate point is really if you can at least appreciate how the strategy works, you can adapt it to all the other questions. So this strategy talks about, first thing, H, heat. Now what I want you to talk about when you refer to heat is really about, is it a heat gain or is it a heat loss? Okay. And then after that, when I talk about direction, I'm talking about from where to where. And also, you have to indicate by putting a bracket which region is of a higher temperature, which I will exemplify for you later. Last but not least, the outcome depends on the question. So are they asking you, is there a gain in temperature, or what happens, when you heat a pan? So it really depends on the question for the outcome. All right, that is where you need to adapt using this strategy. So I'm going to very quickly show you now how is. All right, let's continue with the next question. Before I start, I just want to say that my Apple Pencil seems to be having some issues today. So pardon me if there's any lagginess. Now, in part B, we are going to explain your answer for part A. So we will use the strategy that I have talked about, HDO. So H stands for heat gain or heat loss, D stands for direction, and O stands for the outcome, according to the question. Now, so I've actually asked you to imagine that you are the substance, right? When answering questions on heat transfer. So you can do that by, let's just say, you imagine yourself as the water, because we're dealing with water in the first part. So that's how you can structure your answer. So you say something like, okay, water has gained heat. Now, before you say gain heat, remember I talked a little bit about indicating which region has a higher or lower temperature. So you would say that your water, which has a lower temperature as compared to your spoon, has gained heat from the metal spoon, which in this case is of the higher temperature, thus causing the temperature of the water to increase and the temperature of the spoon to decrease. So let me just highlight it for you so you can see it clearly. Now, so the part on gain heat is on H, and then you have the direction of movement from where to where. Okay? And last but not least, the outcome. So this is how HDO can be used. Let's move on to another question. Now, in the next question, so first thing again, think about the first step is to read that question. Second step, identify the topic. Third step would be to identify the concept. So, Tyler placed the following setup in an air-conditioned room with a temperature of 16 degrees as shown in the diagram. He predicted that the temperature recorded by the thermometer in setup B will be higher than setup A after 1 hour. Do you agree with him? Give a reason for your answer. Now, for this question, we see things like temperature, we see things like degrees Celsius. So this tells you that it is heat, okay? And also, the process skills that we're looking at is talking about predicting. Now, when you have a question that is telling you to predict something, you need to fall back on your prior knowledge. Now, what is prior knowledge? Prior knowledge is talking about knowledge that you have gained in class or from your books, not from this question. Because predicting requires you to relate the phenomenon or the event. Alright, you need to make an intelligent guess of what would happen based on your prior knowledge. So in this question, they talk about temperature and they also talk about putting him in this air-conditioned room. So in actual fact, they are actually testing you on the concept of transfer of heat. Why? Because they're talking about temperature change. So remember, whenever they talk about temperature change, there must be a gain or loss of heat, right? So when there's a loss or gain of heat, that means heat must have been transferred. Either you have gained or you have lost heat. Now, in question A, they ask you, do you agree with him? Give a reason for your answer. Now, in this case, Tyler is not correct. I would say no. Now, do take note that the no alone usually does not give you any marks. You need to give a good reason. Alright? Now, for predicting, there is no strategy because it depends on what you are predicting. So instead, you have to find out what is the prior knowledge that they want you to relate it to. Now, in this case, you need to actually say that because he said that the temperature in setup B would be higher, right? That's what Tyler was trying to say. But Tyler is wrong, okay? Because in order to be higher, heat needs to be gained, okay? However, the only difference is that your woolen socks is being present, but your woolen socks is not giving off any heat. So its temperature cannot be higher, okay, than the thermometer. So because the woolen sock is not any higher, it's not giving off any heat, there is no heat to be transferred from your woolen socks to your thermometer. Alright, when you compare this thermometer A and thermometer B. So what they're trying to say is they're testing you on the concept of prior knowledge of whether you know that your woolen sock is not a heat source. Okay, so answer should be no, because the sock is not a heat source. Thus, thus no heat or rather thus its temperature would not be higher than the thermometer in it. Okay, so when there's not there is not a temperature difference, then there is no heat gain or heat loss. So in question B, they explain to you what is most likely the temperature recorded by the thermometer in setup B if the experimenter is repeated, whereby the woolen socks is replaced by the metal tin. Alright, so in this question, they are testing you on your prior knowledge, because most likely it's like a hint to you that is on prediction. You need to understand that this is actually pointing you towards the direction of heat transfer. Now, remember this. We say that we always say that heat travels from a region of high temperature to a region of lower temperature until both regions are of the same temperature. Okay, so I'm going to pen down. So because of this phenomenon of heat traveling from one region to another region until they are the same temperature, you know that the most likely temperature would actually be 16 degrees. Reason being that the surrounding air-conditioned room is actually at 16 degrees. So given that you know that it's at 16 degrees, it doesn't matter whether is it a metal tin that is surrounding your thermometer. It doesn't matter what is wrapping around the thermometer. Ultimately, whichever region, okay, it will always be 16 degrees. If the thermometer was at a higher temperature, okay, heat will be lost from the thermometer outwards until it reaches 16 degrees. If it's of a lower temperature, it will gain heat until it reaches 16 degrees and nothing more, because the surrounding temperature is at 16 degrees. It's as simple as that. All right. All right, moving on to the next question. We know that we need to read the question first, right? So in this question, they tell you that 2 experiments were being set up using 2 identical glass bottles X and Y. Now, in the question, you see things like hot water, okay? This will give you a hint that it's actually a heat topic. And then you need to ask yourself, all right, what would cause the ink droplet to move from left to right? So this will also give you another hint that, okay, in order for the ink droplets to move either left or right, there must be a push or a pull, correct? And then after that, you ask yourself, okay, so what could cause a push or a pull? So what could cause a push would be that if something occupies more space, right? So in order to occupy more space, given that you understand the concept on matter well, you know that it has to gain heat. And when matter gains heat, it will expand, causing your ink droplet to be pushed from X to Y. So you know that this concept is going to be on expansion and contraction. So in the first question, they asked you, predict how the ink droplet will move, all right, in the above setup after 2 minutes. Now, whenever they ask you to predict, once again, you need to draw on your prior knowledge. And this time round, your prior knowledge and your concept would be on expansion and contraction. When they ask you to predict a movement, always use a point of origin. What do I mean by that? So for example, a point of reference. So instead of saying, it will move that side or move this side, it is very vague. Or move towards, it will move more, without saying any point of reference, you're not going to get the marks. So instead, look at it. If you think that it's going to move in a direction from left to right, is there a point of reference that you can say that's very clear? So in this case, I would say that your bottle Y is a very good point of reference. So I would say that the ink droplet would move towards bottle Y. And then it's very clear already, right? Because you have a point of reference. Explain your answer in A above. Now, when you are attempting expansion and contraction question, the same strategies HDO actually applies, except that there is an additional element known as E or C. So E actually stands for expansion, and C actually stands for, you got it, contraction. So nothing very difficult. The reason why this must be added in is you need to tell me the process, correct? Whether is it expansion or contraction. So when we talk about heat transfer questions on its own, this is not required. Now, you also need to understand that with expansion, there is an increase in size that you need to mention. And for contraction, there is a decrease in size that you will also have to mention. Okay? So when we talk about size, we talk about volume. So let's see how we can apply our strategy. So we can start off by saying that, remember, you need to imagine that you are the substance. So in this case, I'm going to talk about the air, because it is the air that is actually gaining heat, correct? From your hot water. So your hot water will be of a higher temperature as compared to your air. Heat will travel from your hot water to the air. I know many of you be saying, but Mr. Chong, it needs to pass through the glass bottle before it passes through the air. Yes, I know, but you've only got 2 lines, so you tell me the most succinct things. Alright? So in this case, we start off by talking about who is gaining the heat. I will talk about heat gain because it is the heat gain that causes the expansion, so it's more clear that way. Now imagine you are the substance. So I would say that air in bottle X has, okay, so remember once again, bottle X is the region of higher temperature, right? Bracket higher temperature has gained heat from the hot water, lower temperature, okay, so this we have talked about H, and then we also have talked about D. Then remember, for expansion and contraction question, we need to talk about E or C. So in this case, it's E because it's expansion. So this has caused the air to expand. So remember, with expansion, you always must talk about size and increase in volume. That's talking about your size. Hence, pushing, sorry, give me a second. Hence, occupying more space and pushing the droplet to Y. Okay, so this is a very clear and concise way that you can use my strategy to answer this type of question. So once again, I'm going to pen down the strategy. The strategy is H, D, E or C and O. So I'm going to show you. So in this case, gain heat. All right, who has gained heat? Air has gained heat. So this is H. And then you have, where is the direction? So from where to where? And then you talk about expansion. This is caused air to expand and increase in volume. Remember, expansion always increase in volume. And last but not least, you talked about the outcome. Oh. So this is very clear and it's very concise. All right. So next part of the question, C. Without changing the glass bottle or tube, suggest 2 changes you can make to the original setup to make the ink droplet move faster. So in this question, you know it's contraction and expansion, right? So if you want the ink droplet to move this side faster, then one of the ways is actually to cause your gas particles to expand faster, correct? So remember, in order for something to expand, you need heat. So obviously, if I'm gaining heat faster, I expand faster or at least to a greater amount. So one way is to actually use to increase the heat in the water. This will cause my air to expand even faster because now with a higher temperature, heat will travel from the water to the air inside at a faster rate. Or I can always choose to cool down the air inside here. So this will cause your air to actually compress. Sorry, not compress, sorry, my bad, contract. So when it contracts, it occupies more space. sorry, when it contracts, it occupies less space. My correction, contraction, less space. And so your water droplet will be able to move more towards the Y at a faster speed as there's less, or rather there is less space needed by the air particles on this side. Now, the issue with this kind of question is a lot of students will just say, oh, increase heat in the basin with hot water. Or they will say, oh, cool down bottle Y. That is actually general answer, GA. A lot of time you will get 0 marks for answering your question in this manner because you need to tell me in what way. So for example, you want to increase the heat in the plastic basin. All right, you have to tell me something along the lines such as, okay, use hotter water. That's one way. Or you could say place a heat source under the basin to increase the temperature of water in the basin. So it has to be a method. It cannot just be a very general sweeping statement and just go, oh, increase temperature of hot water. It would not work. So the second way, same thing, you have to tell me what you want to do in order to lower down the temperature of bottle X. So you would say something like, place bottle Y in a basin of ice to lower the temperature of the air in Y. Okay, I hope I'm very clear about this. This rule about being very specific about what to do is key in answering questions, and this is something that many students have a problem with because they tend to make sweeping statements, very general statements. All right. Next question. Lydia took the MRT to school one morning. She noticed there was gaps between the metal rails MRT track. Explain why are there gaps on the MRT track. So once again, based on what I've read, I would think that it's actually expansion and contraction. Strategy I would use, it's the same thing that I've talked about, HDEC /O. So first things first, we want to talk about heat. And then when you talk about heat, once again, you need to imagine, all right, which substance you are. And then you need to talk about the direction of a heat gain. So I'm going to imagine that I am actually the metal rails. So I would say that the metal rails gains heat. Okay. From where? Remember, it's always, the direction is always from where to where? From the sun in this case. Sorry, just let me change this. From the sun. This is of course the higher temperature. This causes the rails to, now, so there is E and C. So in this case, based on your prediction and your understanding, it would be expansion. So base causes your rails to expand. So in this case, when you expand in size for the rails, it is more like actually lengthening it. Right? So the gaps in this case, well, think about it. If your rails are going to expand and there's no space to expand, they are going to bend and buckle and cause the train to actually derail. All right. So this causes the rails to expand and increase in length. Thus, remember the question is talking about why are they gaps, right? So thus the gaps allows the rails to increase in length without buckling. Or bending. So once again, let me exemplify for you. HDE/CO. So in the first part, metal rails gain heat. This is talking about H, lower temperature, okay, from the sun, okay, talking about direction. The next one is causes the rails to expand and increase in length, and talking about the outcome, which in this case relates to the question, right? So the gaps are there to actually allow for expansion, which prevents the rails from bending. Now, in question 5, let's take a look at it. Reuben conducted an experiment with two identical beakers. Look, they always like to talk about two identical beakers and everything else because there can only be one variable, one change variable in any experiment. That's something that we need to know, okay? He wrapped beaker B with bubble wrap, plastic sheet with air pockets. He then poured hot Milo at 80 degrees into each beaker. He measured the temperature of Milo in each beaker for 20 minutes and drew a line graph of changes in temperature. So in this question, they're actually talking about good conductors and poor conductors of heat. So what is the hint questions? Air pockets. This, based on your prior knowledge, you should know that air is a poor conductor of heat. So based on that, because you know that it's a poor conductor of heat, you would know that this question is probably talking about conductors of heat. And the process scale is they want you to be able to interpret or explain the observation of data. Now, for this, right, the strategy identified here is actually CER, claim, evidence, and then reason. All right. Now, your claim is talking about what is your answer? A, B, C, D, E, F, G, based on the questions. So in this case, we only have B or C, right? And then after that, your E is actually your evidence. Your evidence means what you can observe from this particular graph. You have to state it there. And then your reason is related how it helps in your purpose. All right. So let's take a look. Based on the graph, which beaker, B or C, kept the Milo warm for a longer period of time? Explain your answer. So in this case, I would need to look at the graph. So at the end of, sorry, this should be the 20 minutes. Let me do some correction. There's error in the question. We notice that B is actually of a higher temperature. So this tells me that heat is actually lost. All right, it's actually lost at a slower rate than C. Because if you take a look at it, at every single time unit, C is always lower. So when C was here, B is actually here. C was here, sorry, let me change the color. Yes, when C was here, B is here. So at every time unit, B actually has a higher temperature as compared to C. This tells me that heat was actually lost at a slower rate. So whatever that is happening, it means that B that was wrapped with the bubble wrap has actually prevented heat from being lost. Now, if you remember correctly, the concept of conductors of heat talks about whether it allows heat to flow through it quickly. A good conductor of heat will allow heat to flow through it very quickly as compared to a poorer conductor of heat. Now, you need to be very careful. Whenever you talk about conductors of heat and there are two items, you need to compare. So the word to use should be not just be poor conductor, you should say poorer conductor. Alright, because you're comparing the two. Alright, it's always a relative term. So let's jump back to our question. Based on the graph, which beaker, B or C, kept the Milo longer for a period of time? Explain your answer. So in this case, I would have to go with B. So that's my claim, right? And then my evidence in this case, I would say that from the graph, it shows that beaker B has a higher temperature than beaker C. So this is my evidence. And the last part, which is R, which is the reason. So that is actually your explanation in this case. So remember, you need to relate your concept that you have learned and your explanation. You need, when you're generating your explanation. So you need to say that, remember, I said that air is actually a poor conductor of heat. So because of that, it would not allow heat to pass through this pocket of air easily and be lost to the surrounding. So you can actually use my strategy of HDO to answer this question. However, you need to add in the element of why heat cannot be transferred quickly. So you can say that the air pocket or you could straight away say that air is a poorer conductor. Now in this case, you don't have to use poorer because you're not comparing two results. It's either you have it or you don't have it, the bubble wrap. So in this case, it's just poor because there isn't a comparison between two materials. You realize the other beaker doesn't have. So you just say it's a poor conductor of heat. Hence, heat cannot be lost from the hot Milo to the surrounding quickly. So once again, you see in my answer, I have talked about air is a poor conductor of heat. This is something that's new, but the element of talking about a transfer of heat, see, cannot be lost, and the element of talking about direction from the hot Milo to the surrounding is still there. And actually the outcome is part of it also, which is this part. Alright, so looking at the second part of the question, state another variable that has to be kept constant to ensure a fair test. So this fair test concept, right, it is something that is always being asked. So in order for it to be a fair test, there can only be one variable. Everything else has to change. So the key thing is you need to take note is another variable. So in this case, they already talked about identical beakers. So you cannot use identical beakers. They also talked about the temperature being the same. So what you can actually talk about is any other thing that is not the temperature, not the beaker. So in this case, I would say that volume of liquid. And in this case, it would be your Milo. Alright. Moving on to question 6. So once again, read the questions. So you will realize that a lot of time, right, when you see the word air spaces, it hints you to poor and good conductors of heat. So the question goes, pizzas are usually delivered in corrugated cardboard boxes which have ridges with air spaces in between as shown. Explain why these boxes can keep pizzas warm for a longer period of time. So the strategy here for poor conductors or good conductors is P or C, which stands for poor or good conductors of heat. Okay, so it should be P or G, poor or good. Alright, and then you need to talk about speed because whether or not something is good or poor conductors, once again, is related to how fast, not how easily. The keyword is how fast it allows heat to pass through it. Alright, and then you talk about the outcome as shown. So let's go ahead and attempt this question. So you need to tell me that the first thing is poor or good conductor, right? So air spaces. So you need to relate to the idea that the air is the poor conductor. I'm not talking about the cardboard. Students tend to think that it's the cardboard. No, the cardboard is just to contain the air. The air is the one that is the poorer conductor. So you have to say that air is a poor conductor of heat. Hence, it does not allow heat to pass through it quickly. And lastly, you need to talk about the outcome. The air spaces would hence prevent heat from being lost quickly from the pizza to the surrounding. Therefore, maintaining a higher temperature, if you want to add the last line in. So let's go ahead and dissect this thing as usual. So, poor conductor of heat, we're talking about P or G, does not allow heat to pass through it quickly. We're talking about speed over here. And then the outcome is that the air spaces prevents the heat from being lost quickly from the pizza to the surrounding, therefore maintaining a higher temperature for your pizza and keeping it warm. Alright, we have arrived at our last question. First step, read the question. Mrs. Lim wanted to grill the meat in the oven. Typo error here. She decided to conduct an experiment to grill a few pieces of meat at 100 grams each at different temperatures in the oven for 15 minutes as shown. She then sliced the pieces of meat into two and made the following observation. The results of her experiments are shown in the table below. Alright, so then they show you a table. Continuing, Mrs. Lim decided to grill a thicker piece of meat of 200 grams at 210 degrees Celsius. Based on her results, would the time required to fully cook this piece of meat be more than, less than, same as 15 minutes? Explain your answer. So in this case, it's obviously a data question. So you're going to have to provide evidence as to why the meat would actually require more than or less than 15 minutes. So if you take a look at it, they're referring to 210, correct? So this is 210. Now, she cooked it in her oven for 15 minutes, and at 210, it is fully cooked. However, it is actually at 100 grams only. So that's what we need to understand. So at 100 grams, okay, it can be fully cooked. Alright? So definitely at 200 grams, you would need more time. Correct? So you need to recognize that fact. So you're actually inferring that since it can only be a 100 gram piece, which is actually less mass than 200 grams, takes 15 minutes to be fully cooked. Anything at a lower temperature will not get it cooked in 15 minutes as shown, it's only half cooked. Therefore, you would assume or you can infer that if I were to use a thicker meat of 200 grams, okay, something with a higher mass, it will actually take a longer time. Now, this has got to do with the fact that 200 grams is actually thicker than 100 grams. So what happens is that it needs more time because now you are comparing at the same temperature, 200 grams at 210 degrees Celsius, right? Temperature is the same. But what is different is the cut of the meat. So basically, you have one that is 100 grams, and then you have one that is thicker at 200 grams. So they are both subjected at 210 degrees Celsius. However, for the 100 grams, alright, it is thinner. So therefore, heat requires a shorter amount of time to reach the center in order to fully cook the meat. However, if you take a look at the 200 grams, it's a lot thicker. So because it is a lot thicker, right, you have to account for that, and it will take more than 15 minutes from the heat in the surrounding to travel all the way to the center of the meat to actually get it fully cooked. Alright? So therefore, I would say that it is actually longer than 15 minutes. Now, then you are asked to explain your answer, correct? So the first thing you need to tell me is that it takes 15 minutes to cook 100 gram meat. Therefore, a 200 gram meat, which is thicker would require more time for the heat to travel from the surrounding to the center of the meat. Okay? So this has got to do with heat transfer once again. Now, I've come to the end of my lesson for today. I hope that the strategy introduced is useful for you. So I would like to do a very quick recap. So whenever you're attempting any question, it is always good to read the question, identify the topic, and zero in on the concept before jumping into doing the question. The second point is that you would really want to recognize that certain things is common for heat or strategy for answering heat questions. One thing is always talking about heat gain and heat loss, as well as, you know, from where to where does the heat travel from. That is actually very important. So you see that in expansion question. You also see that in heat transfer question. Even poor and good conductors of heat questions, you also see the part whereby you have to talk about whether something is gaining heat or losing heat and from where to where. So these are the common things that you need to really take away when attempting these questions, and you should be fine. So thank you once again, and you have a good day.